Surveyor's vernier engines were fired for 14 seconds, about 18 hours after launch, to reduce landing velocity. Immediately after the firing, telemetry indicated that the compressed helium used to pressurize the vernier system was leaking through the regulator valve. A small particle had probably stuck in the valve seat. 3 vernier engine firings were commanded in an attempt to get the regulator valve reseated, but without success. Emergency tests at Edwards Air Force Base and at the Hughes facility in Placerita Canyon were run to determine minimum helium pressure and propellant requirements for an emergency soft landing. The plan, while ample helium pressure was still available, reduced the spacecraft's weight by burning all excess vernier engine fuel. The fuel could not be used later during the terminal descent because of the loss of helium pressure. By lightening the spacecraft, the thrust needed in the vernier deceleration phase would be reduced. Next, reprogram the terminal descent so as to defer retrorocket firing to the last possible moment, thus minimizing the period during which the vernier engines would have to cancel lunar gravity. Development of a new terminal descent sequence normally takes 4 to 6 weeks. For Surveyor 5, it was accomplished in 40 hours, ending when the spacecraft touched down on the moon on September 10, approximately 18 miles northwest of its original target site in the Sea of Tranquility. The first lunar chemistry set is shown in this picture, ready to do its job of analyzing the composition of the lunar soil. At the Jet Propulsion Laboratory, work continued on the mosaic, showing details of each of the Surveyor landing sites. In all, Surveyor 5 sent more than 18,000 pictures during the first lunar day and transmitted a total of 86 hours of alpha scattering data. Perhaps the most eagerly awaited of the Surveyor 5 results were those from the alpha scattering instrument, which provided the first direct measurements of the chemical composition